Welcome back. This is exercise 3.4 and it is fully based on elimination method. This is the first question, this is the first subdivision. It says x plus y equal to 5, 2x minus 3y equal to 4. So these are the given equations. Since we have already discussed how to do elimination in the introductory class, I am directly going into the steps. So the main step that we have to do in elimination method is we will be trying to cancel out one of the variables. So if I see the question, I have x plus y equal to 5 as my first equation and 2x minus 3y equal to 4 as my second equation. So if I am looking for cancelling out any one of the variable, I see that if I multiply the first equation with 3, I will get a 3y and apparently I have a minus 3y in the next equation which can be cancelled. So I am choosing to multiply the first equation with 3. So first equation into 3 will be 3x plus 3y equal to 15. Then the second equation is written as it is, that is I am multiplying it with 1, so there is no change. So 2x minus 3y equal to 4. So now I see that I get a plus 3y and minus 3y. So I cancel both of them. I will be left with only the x term and the constant term. So when I add these two, it is 5x. When I add these two, it is 19. So the value of x would be 19 by 5. So after obtaining the value of x is equal to 19 by 5, I substitute it in any one of the equation. I have taken equation 1. So when I substitute the value of x here, I get y is equal to 5 minus x. So y will be 5 minus 19 by 5. So y would be taking LCM 25 minus 19 by 5, which is nothing but 6 by 5. So the value of x, y is 6 by 5 and x is 19 by 5. So that is the solution. We get x as 19 by 5 and y as 6 by 5. Moving on to the second question, the equation given to us is 3x plus 4y equal to 10 and 2x minus 2y equal to 2. So here again, if I want to cancel out any of the variable, I see I have a 4y and a minus 2y. So I can multiply the second equation with another 2 so that this 2y becomes 4y. So plus 4y and minus 4y can be cancelled. So first equation I multiply it with 1, so it remains as it is. So 3x plus 4y equal to 10. The second equation by 2, which is 4x minus 4y equal to 4. I see that plus 4y minus 4y cancels off. So adding x gives me 7x, 10 plus 4 is 14. So on simplifying, I get my x value as 2. Now I substitute x is equal to 2 in the first equation. So I get 3 times 2 plus 4y equal to 10, which is 4y is equal to 10 minus 6. Or 4y is equal to 4, y is equal to 1. So the solution that we obtain for x is 2 and y is 1. This is the third subdivision. The question given in the book is this: 3x minus 5y minus 4 equal to 0 and 9 is equal to 2y plus 7. So we have to first make them into a proper linear equation format. So I have taken x and y one side and kept the variable to the other side. So I am just took that 4 to the other side. So I got 4 plus 4 here. And in this question I have got 2y to this side. So I will have 9x minus 2y equal to 7. This is my second equation. So in this equation again, if I see, I have a 3 and I have a 9. So if I multiply the first equation with another 3, I will get a positive 9 here. Then I can subtract these two so that 9x and 9x will cancel. So I am taking the first equation and multiplying it with 3. So I get 9x minus 15y is equal to 12. And the second equation I am writing it as it is. So it is 9x minus 2y equal to 7. I see both of them are 9x and 9x. So in order to cancel them, I need to subtract one equation from the other. So I am subtracting it. The signs of the second equation will get changed. So this will be 9x, this will be minus 9x, so they get cancelled. Now I have a 15y and plus 2y because of change in sign. Then 12 minus 7. So when I do this, I get minus 13y is equal to 5, or y would be minus 5 by 13. Now moving on to the next part, we substitute y is equal to minus 5 by 13 in equation 1. When I substitute this value in equation 1, I get 3x is equal to 4 plus 5y. So 3x would be 4 plus 5 times minus 5 by 13, which is there. Then I take LCM. Once I take LCM, which is 13, I get 3x is equal to 52 minus 25 by 13. So 3x would be 27 by 13. Taking the 3 down, I get x is equal to 27 by 13 into 3. Because 3 is multiplying here. When it goes that side, it becomes the division. So 3 and 27 cancels 9 times. So I get x is equal to 9 by 13. So this is the solution. Last subdivision in the first question. It's given x by 2 plus 2y by 3 is equal to minus 1 and x minus y by 3 is equal to 3. So this is the second equation. So here we see that there is a positive and a negative, which will be easy for cancelling, and here you have y by 3 but here you have 2y by 3. So if I multiply this equation with 2, I will get a positive 2y by 3 and a negative 2y by 3, which will become easier for me to cancel. So the first equation I multiply it with 1, so it remains as it is, which is x by 2 plus 2y by 3 is equal to minus 1. And the second equation, when I multiply with 2, this becomes 2x minus 2y by 3 is equal to 6. I see that plus 2y by 3 minus 2y by 3 are there. I can cancel them. I'll be left with x by 2 plus 2x, and on the other side it's minus 1 plus 6. So this calculation I've showed you. You have x by 2 plus 2x. So you're taking LCM, so x plus 4x by 2, so it will be 5x by 2. So here you will have 5 by 2x, that is equal to 5. Now from this, if I eliminate my x value, x will be 5 into 2 by 5. 5 will cancel, so my x is 2. So once I obtain my x value, I substitute x equal to 2 in the second equation. And I go to the second equation, I have 2 minus y by 3 equal to 3 because I have substituted 2 in place of x. I'll have minus y by 3 is equal to 3 minus 2. So minus y by 3 would be 1. So minus y would be 3 because I have to cross multiply. So my y becomes negative 3. So the value that I obtained for x is 2 and my y is minus 3 in this problem. The second question on the first subdivision, it's word problem. It says there is a fraction. So first assumption that we make is that the fraction be x by y. So x is one unknown, y is the other unknown, and the condition given is when 1 is added to the numerator and 1 is subtracted from the denominator, the fraction becomes 1. So that is the first condition. Second condition, numerator you don't do anything, you add 1 to the denominator, the fraction becomes 1 by 2. So now what we do, this is in the form in the correct linear equation format. So we do the cross multiplication and bring it down to the equation type. So when you cross multiply this, you get x plus 1 is equal to y minus 1, and you collect all x and y's one side. So x minus y is equal to minus 2. This becomes your first equation. And here again when you cross multiply, you get 2x is equal to y plus 1 or 2x minus y equal to 1. This becomes your second equation. Now we have to solve these two equations by elimination method. I have written the first equation and the second equation as it is. I am not multiplying or dividing with anything because I already have minus y and minus y. Just when I subtract them, this equation y will get cancelled away. So I am just changing the signs of the second equation. So my minus y and this plus y gets cancelled off. So here I have 1x minus 2x, which is minus x, and minus 2 minus 1, which is minus 3. So x will become 3. So after obtaining x is equal to 3, I substitute this in any one of the equation. I have substituted in equation 1. So when I substitute in equation 1, I have 3 minus y equal to minus 2. So minus y will be minus 2 minus 3. So by minus y will be minus 5, y would be 5. According to our assumption, the fraction is x by y. So our required fraction would be 3 divided by 5. This is the second subdivision in the second question. So this is basically a word problem with age identification. So here we are assuming the present age of Nuri as x years and Sonu as y years. So this is our first assumption. So there are two conditions that are given in the question. One is 5 years ago the relationship between their age, and 10 years later the relationship between their age. So it says 5 years ago. When I say 5 years ago, I have taken the present age as x and y. So I subtract 5 from both of it because it happened 5 years ago. So x minus 5, y minus 5. It says Nuri's age is 3 times that of Sonu's age. So this value is equal to 3 times this value. So when I simplify this, I get x minus 3y is equal to minus 10, which is my equation 1. Then a condition is given 10 years later. That means 10 years from now, I am taking it as x plus 10 and y plus 10 because the present age is x and y. So after 10 years, it's going to be x plus 10 and y plus 10. And the relationship is Nuri would be 2 times the age of Sonu. So when I simplify this equation, I get x minus 2y equal to 10. This is my second equation. Now I have two equations. I am solving them by elimination method. And here when I see, I have x and x as the variables are having the same coefficient in both the equations. So I just change the sign of them. I am subtracting one from the other. So I change the sign of the second equation and I see that this x and this minus x get cancelled. So I will be left with minus 3y plus y minus 10 minus 10. So minus y is equal to minus 20 I will get. Minus minus would cancel, so y would be 20. So the age of Nuri is 20 years. The age of Sonu is 20 years. So when I substitute y is equal to 20 in any one of the equation, I will be able to find out the age of Nuri. Now let's substitute y equal to 20 in equation 1. When I substitute it in equation 1 is here. So it's going to be x is equal to minus 10. This minus 3y goes that side, becomes plus 3y. 3 times 20 because your y is 20. I get x is equal to 50. So the present age of Nuri is 50 years and Sonu is 20 years. This is the third word problem. and this is based on the digits. So we are assuming one digit to be x, the other digit to be y. Therefore, the number will be x and y. So it's a two-digit number with one digit x and the other digit y. So the number will be x and y. So before starting into problems like this, we must understand how the digits are represented in the equation. For example, if you have 27 as a number, it's going to be written as x and y as per our assumption. So one digit is taken as x, the other digit is taken as y. But when I write 27, I mean it's 20 plus 7 because 7 is in the ones place and 2 is in the tens place. So it's going to be 20 plus 7, which is 27. Therefore, when we represent a two-digit number in the form of an equation, the x variable, which is in the tens place, need to be multiplied with 10. So when I say sum of these two digits, it's not just x plus y, but it is 10x plus y. 10x plus y is the correct formation because the x is in the tens place, so 10 need to be multiplied. Okay, with this concept, let's jump into the question. It says the sum of the digits is 9. So I'm just adding the x value and the y value, which is equal to 9. I'm getting the first equation. And there is a condition given for the second equation. It says 9 times the number is 10x plus y according to that explanation, will be 2 times the number obtained by reversing the digit. So x goes to ones place and y comes to tens place, that is reversing the digits. So when I do this and simplify, I get an equation 88x minus 11y equal to 0, and this becomes my second equation. I'm trying to solve the first and second by elimination method. I have a plus y, I have a minus 11y. So what I do, I multiply the first equation with 11. So when I do with 11, I get 11x plus 11y equal to 99. And the second equation I multiply with 1, so it remains as it is, which is 88x minus 11y equal to 0. Here I have plus 11y minus 11y, which cancels each other. So I'll be having 99x is equal to 99. I'll be getting my x is equal to 1. So after getting my x as 1, I substitute that in equation 1. I get y is equal to 9 minus 1. So y would be 8. So therefore the digits would be 1, 8. 1 corresponds to your x and 8 corresponds to your y. Therefore the number would be 18. This is the fourth subdivision. In this, Meena goes to a bank and she is withdrawing 2000 rupees and she is taking 50 rupees and 100 rupee notes. So the question is, how many 50 rupee notes and how many 100 rupee notes did she take? So first thing is, I assume the number of 50 rupee note to be x and the number of 100 rupee note to be y. So according to the question, totally she has 25 notes in her hand. So the sum of 50 rupee notes and the sum of 100 rupee note together is 25. The count is 25, which is the first equation. Then the denomination is given. So 50 rupee note, x number of notes, 100 rupee notes, y number of notes. Together it makes 2000 rupees, which is the money that she withdraws. So now we have two equations. What I do is, I see that the first equation is very simple and the second equation has complicated numbers. So I multiply the first equation with 50. Why I am multiplying with 50? Because I can make both of these terms as 50x and 50x and I can cancel it. So when I multiply with 50, I get 50x plus 50y is equal to 1250. And the second equation, I leave it as it is with multiplying with 1. So I get 50x plus 100y is equal to 2000. When I subtract these two, literally I will change the sign of the second equation. This 50x and minus 50x cancels. 50y minus 100y is minus 50y and this minus this is minus 750. So when minus minus cancels, y would be 750 by 50, y will be 15. So after obtaining y is equal to 15, substitute y equal to 15 in the first equation, I get x is equal to 10. So we conclude that in she has got 10 50 rupee notes, which makes 500 rupees, and she had taken 1500 rupee note, which makes 1500 rupees together, which has been withdrawn by her, which is 2000 rupees. This is the last question in exercise 3.4. So this is a problem where a library is lending books with fixed charges and additional charges, and the condition given is the fixed charges are taken for the first 3 days, and after the third day an additional charge of y per day is being charged. So there are two situations given. One is a person named Sarita, she is lending a book for 7 days. So 7 days corresponds to 3 days of the fixed charge plus 4 days of the additional charge. So if I take x as the fixed charge and y as the additional charge, this would be x plus 4y equal to 27. That is my first equation. Another person to see for 5 days. So 5 is taken as 3 for the fixed charges and 2 for the additional charges. So the equation would be x plus 2y equal to 21. This is my second equation. So when I look into the equation, I already see that x and x are same. So it is just enough for me to subtract one from the other to cancel the x variable. So when I subtract the second equation from the first one, I see that the x and x cancels away. This becomes 2y and this will become 6. So y would be 3. So once I obtain my y as 3, I substitute y equal to 3 in equation 1. So when I substitute it here, I get my x is equal to 27 minus 12 or x is equal to 15. Therefore, we understand from this that the fixed charge for 3 days is 15 rupees, whereas rupees 3 is charged for every additional day after 3 days have been over. With this, we have come to an end of exercise 3.4. We'll continue exercise 3.5 in the next lecture. Thank you.